my name is Sher and I'm an SAT Math tutor. Last time, you saw me do the Oxford MAT without studying. Am I going to be doing that again today? Yes. Is it taking longer than I expected? Definitely. Am I going to see it through though? Of course. So, if you like watching these sorts of videos, be sure to subscribe so you get notified when new videos come out. Let's get on to it. Alright, let's look at section 4. So, a function is said to be even if this equals to this. Oh, well, this one, oh yeah, I forgot. We have to write it in the blank space. So, IA first. So, an even graph is basically something that has mirror symmetry like this. So, even functions, let me write it a bit more nicely. Even functions are symmetrical about the y-axis and have mirror symmetry. Whereas odd functions have rotational symmetry. So what it looks like is like this. So they look the same, it's just that it's kind of flipped. Have rotational symmetry of 180 degrees. Symmetry of 180 degrees. Right, that was the next part. For this graph, this line makes an angle theta with geometrically explained by a naught. A theta plus, do they accept graphs? It would be so much easier because if this is the positive, when theta is positive, but if theta is negative, it goes underneath here instead. I mean it is Oxford. I would assume that they would allow something like that. So I'm just going to assume, yes, I'm just going to draw a little diagram here. This is y equals to x. This is, what was this other graph? X plus y equals to 1, and our line L. So I'm going to just draw a little diagram. So I'm going to say that this is area, can't use A, can't use B. I'm going to use M and N. So A theta is equal to area M plus area N, whereas a negative theta, so it will look like this, is actually the subtracted version, is equal to area M minus area N. We also probably should figure out what area M is. This is perpendicular. Area M equals to, so you can see that this area M is half of the big triangle, and if you just use half times base times height, you can just do area M is half of half times 1, which equals to a quarter. So area theta plus area of negative theta equals to area M plus area N plus area M minus area N. A theta plus a negative theta equals to 2 of area M, and we know M is already 1/4. This is going to be 1/2, so shown. Alright, now B. Determine the formula for A theta. Great, alright. Okay, so here's the thing. We've got our diagram there. So L is a straight line. We probably should find the slope first. Slope for sum equals of L equals to y over x. if you notice, y over x is literally just theta plus 45 equals to tangent theta plus 45. So equation of L, y equals mx plus b. The b is origin. Alright, let's look at part B. So, determine what A is. Alright, so let's look at, we obviously need L first. L is the important bit, so let's just call this point x comma y. So I need space, but anyway, the slope for L would be y over x, and basically y over x, this is y, this is x, is going to be trigonometry, tangent theta plus 45. So if you want to write out the equation of L, it's going to be y equals to mx plus b. So our m is literally this tangent theta plus 45. We basically want to find the area of the triangle. This is the base, which is 1. We probably want the height, which is y. We have to solve for y. Basically, it's this point where L intersects y plus x plus y equals to 0. So x plus y equals to 1. So x equals to 1 minus y. I'm going to name this equation 1. Equation 2, we're going to plug equation 2 into equation 1. Y equals to 1 minus y, tangent theta plus 45. And if we try to isolate for y, we should get y equals to all of that plus y tangent theta plus 45. So y would just be tangent theta plus 45 divided by tangent theta plus 45 plus 1. And I'm pretty sure they probably don't want the tangent theta plus 45. Using the sum formula, y should equal to tangent theta plus 1 over 1 minus tangent theta over, same thing, tangent theta plus 1 over 1 minus tangent theta plus 1. Get rid of all that 1 minus tangent. It's going to be tangent theta plus 1 over tangent theta plus 1. Did I mess up something? Oh, yeah, no, that's right. Plus 1 minus tangent theta. Oh, I'm running out of space. Y would equal to tangent theta plus 1 over 2. Alright, so we now know y. Basically, to find the area of the triangle is just y times base. So A naught is just equal to theta is equal to half times base times height, which equals to half times 1 times tangent theta plus 1 over 2. And A theta would equal to tangent theta plus 1 over 4. That's it. That's our answer for A. Sketch the graph. Great. It's a tangent graph. And we should just write it out some things. 1/4 tangent theta plus 1/4. So how tangent graphs look like? They look like this. So this is probably going to be close to our answer, but we're going to have to figure out a few things. So at this point, if it's 1/4, so it gets squished by 1/4 and then moved up by 1/4. So this is going to be 0, 1/4. I'm probably going to have to draw the axis. So right here, we shift the axis down and we squish it a bit. So this is 0, 1/4. what is the range anyway? For negative 45 to 45, so I don't have to draw the entire thing. Because this is at 90 degrees. Anyway, do I have to show, does it include 45? Where's the thing? 45 to 45, it doesn't include. So anyway, tangent 45 is 1. It's just 1/2, and it looks like this then. So we don't include these 2 points. When theta is 45, this is 1/2. When theta is negative 45, this is 0. Because 1/4, a negative 1/4 plus 1/4. Alright, that's my answer for C. And then, what symmetry does the graph of A0 have? Well, it's odd symmetry because all tangent graphs have odd symmetry. It's an odd, well, is it odd? Do we say odd? Do they want symmetry or do they want like even or odd? Identity in part 2A. This one. Okay, I see. So A theta plus A minus theta. In light of that, it would be A plus, it would be odd. Odd, as all tangent graphs have rotational symmetry, and they are all odd anyway. Alright, okay, let's look at that. That was D, and what about E now? Without differentiating, explain why. Because it's an inflection point. I mean, you can tell in the diagram. Since theta equals to 0 is an inflection point, hence d 2a over d theta square should equal 0. So basically an inflection point occurs when you've got a graph that's it looks like this or like this, an S-shaped graph. If you've got a stationary point that's like a vertex. Okay, and is that all for this one? Great, alright, we're done with this problem. Alright, and let's look at question 5. Miriam and Adam are eating sweets. So Miriam eats as many sweets on any day as there have been sunny days. Adam eats sweets only on rainy days. Okay, here's an example. Great. So Miriam can eat on rainy days too. She just eats the same as the previous. So far 1, 2, 2, 2, 3. Okay, so she can only eat in ascending order. Whereas Adam, well, it doesn't seem like a very good deal for Adam. Adam can eat. Oh, so he can only eat on rainy days and same number. Alright, so if the holiday has 30 days, 15 of which are sunny, 15 are rainy, which would lead Miriam to eat the greatest number of sweets in total, and which one the least number? Well, if Miriam can only eat in ascending order, you probably want more zeros at the front and then counting at the back. So probably rainy, 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 then sunny, 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 and then flip the other way for the most. So let me just put it down there so you can work that out. So if she has rainy, rainy, rainy for 15 days in a row, and then sunny, sunny, sunny for another 15 days, that would be 0 plus 0. So least would be like 0 plus 0 plus 0 15 times. So that's 0 plus 0 plus 0. 15 times basically is just 0. Plus 1 plus 2 plus 3 plus all the way to 15. This would just give us arithmetic sequences 1 to 15. 15 over 2 times 1 plus 15 is just going to be 15 times 8, 1, 2, 5, 6, 120. Whereas the most would be if you put sunny first and then rainy. So that would be 1 plus 2 plus 3 all the way to 15 first, and then we add 15 times. Alright, so that would be 120 here plus 15 times 15, which is 225. So 120 plus 225 would give us 345. There we go. So that's the least, that's the most. Show that in the two cases mentioned in part 1, Adam eats the same number of sweets as Miriam. So for rainy, I have to write that part 2. Rainy, start rainy 15 times. Sunny 15 times. Adam, so number of sweets would be rainy. He would just eat 1 plus 2 plus 3 plus ... plus 14 plus 15, and then on sunny days he can't eat. So this is just 120. What about the other way around? So sunny, sunny, rainy, rainy. 15 times. He won't be able to eat on sunny days. He will only be able to eat on rainy days. So starting from 16 plus 17 plus all the way to 30, I guess. So 29 plus 30, which is just, again, arithmetic sequence formula. 15 terms divided by 2, 16 plus 30. That's just 15 times 46 divided by 2, 23, which would be 345. There we go. Okay, and what is the next bit? Suppose in a sequence of sunny and rainy days, we agree to swap a rainy day with a sunny day that immediately follows it. How does the total number of sweets eaten by Miriam change? How does sweets by Adam change? Alright, so part 3. So initially, if it was rainy and sunny, and then we have Miriam and Adam. So if it was rainy and Miriam ate some M amount, then the next day Miriam would eat M plus 1. Adam would eat some A amount, and the next day he could eat 0. So the total would be 2M plus 1, whereas this one is still A. And then when we swap sunny, rainy instead, Miriam, Adam. So trying to think. So this instead would be, so because it's a sunny day, she can go up by 1. It won't be M, it will be M plus 1. And then M plus 1 because it never goes down, so it has to stay the same. Whereas Adam can't eat on the sunny day, but he can eat on the rainy day, and that is 1 day after A. This is going to be A. In total, this is 2M, 2A plus 1. 1 day after that. This is 2M plus 2, A plus 1. So Miriam, how do you spell Miriam? Miriam eats 1 more sweet. Adam eats 1 more sweet. Alright, and then the last bit here. If they have 15 sunny days and 50 rainy days, must they eat the same number of sweets in total? We just proved that 15, 15, 15, 15. Adam eats the same number as Miriam. And we just proved that if we swap them, rainy, sunny, sunny, rainy, they both increase and decrease by the same amount. So how would we write this properly? Yes, at least gonna have to stop this. It's not the noise. Alright, let's look at the last part. So if the holiday has 15 sunny days and 15 rainy days, must they eat the same number of sweets in total? Explain. Well, we already proved that in 2's cases, they are going to be eating the same. And we also proved that if we swap the order, it's also going to be, they both increase or decrease by the same number. So they're going to eat the same number of sweets, but how would we write it down in like a way? Yes. In part 2, 1 and 2, I get 1 and 2, do we write 1 and 2? Yep, in parts 1 and 2, we have proved. In parts 1 and 2, we've proved that in 2 scenarios with 15 rainy and 15 sunny days, Miriam and Adam eat the same number of sweets. In part 3, we proved that when a rainy day is swapped with a consecutive sunny day, both Miriam and Adam total sweet count increase by 1 and are still the same compared to each other. This means that no matter how much you switch, even though they will increase or decrease by 1, by 2, it doesn't matter, they are still going to be the same. So I'm just going to have to put that in words, I guess. Hence, for any combination, both Miriam and Adam's total count will increase or decrease by the same number. Yep, that's a good one. By the same number, and they will still eat the same number of sweets. Sweets, and that's it. I think that's all we have to write. And they'll still eat the same number of sweets. Number of sweets. And I believe that's it, because the next section is for people doing computer sciences, and I've never done computer science, so I guess I get to stop right here. And And that was the entire Oxford MAT paper. Honestly, I think people think that it's hard because it's written in a different format people are used to, has some out-of-the-box questions, and requires some critical thinking. I did it without studying, so I think somebody who's studied and prepared would be able to take this test just fine. Anyway, if you liked watching this video, be sure to leave a like and make sure to subscribe so you get updated on future videos. Thanks for watching!